Okay, we now look into the limits law, in the second subsection, So the limit law obey this few 1, 2, 3, 4, 5, 6, 6 law here, So the sum law, if you have two function, fx and gx, Contoh, for example, you have like fx is 2x plus 3, and then here you have like polynomial function like this, if the function added together, you can separate it using sum of law, meaning that the limit for the function fx is equivalent to the answer for this is limit of the function fx as x approaching a plus limit gx as x approaching a. Difference law also applied the same. You can separate it. The limit belong to each function here, fx and gx as shown in here. And constant multiple law. Let's say you have a constant and multiply with that function. So you can bring the constant outside and take the limit of that function first. Product law meaning that you have two function here, fx and gx. This one also can be combined, meaning, sorry, can be separated. Meaning that limit fx as x approaching a, you do it at 1, and then dot with the, or multiply with the limit gx x approaching a. Quotient law, if let's say limit x about approaching a, fx divided by gx, you can separate it this way, only if the bottom part is not equivalent to 0. Power law, same as the multiple law just now. You can take the limit of that function first, and then power it. Meaning that, let's say it's power 2 or power 3 and so on. All right. The question here says that number one, what is limit of a constant function? So let's say we have the function. Sorry, the function is constant. You don't have anything that is independent variable, that is very dependent variable. It's just a number. Limit, for example, like limit x approaching 4 for number 8. So the answer is that number. Because there's no variable in it, and there's no independent variable. There's no x, there's no y, there's no dependent variable, and there's no independent variable even. Therefore, whatever limit exists that number, we always get a number. Which is number 8. Which is C here. What is the limit of a linear function? Okay, sorry. Limit of the linear function depend on the value of x. The answer is depend on the value of x approaching. So as x approaching whatever value, this one, x approaching a, so the answer of this limit is a. As limit of x approaching b, for example, is this one, the answer will be b. So it depends on the limit itself. Okay. All right. Now let's look at the how we evaluate limit of a function. If a function, be it linear, polynomial, or rational function, is continuous at x equivalent to a, meaning that continuous at x equivalent to a, at this particular point, it is connected. Oh, let me move this one. All right. So we can use direct substitution to evaluate the limit. For example, like, okay, this is the function. Hold on. Sorry. This is the function, 2x plus 5. So this is actually the fx here, where x is actually the independent variable, independent variable, right? So it is a linear what to call linear function. You only have 2x plus 5. 5 is just a constant number, and 2x here. So it's a linear. So what is the answer if the limit x approaching 3. Yeah? So we use the what you call the sum law here. 2x plus 5. Eh? So for this case, fx is 2x, gx is 5. Okay? So what we can do, we can separate it. Limit, okay, sorry. You can separate it, like this, limit 2x, x approaching 3 plus limit 5, x approaching 3. So as I mentioned in here, if you have a constant, like this, it's a number, there's no x here, there's no independent variable here, you will always get that number, which is number 5, right? For this one, as limit 2x and x approaching 3, what will be the answer? 2 is a constant. You use this constant multiple law here. C is the constant here. 2 is the constant. So you can bring 2 outside. Okay? 2 is the constant, multiply with fx. Multiply with x. 2 you can bring outside and then limit x. Limit x only. And x approaching 3. So limit x approaching 3. And this is continuous at x equivalent to a. So you replace the x here with the limit here, x approaching 3, you replace it with 3. So 2 times 3, you get 6. And this one is the constant limit. You will get back the number. 6 plus 5 will get 11. All right. Next example, 1.2. Evaluate, okay, this is polynomial. Evaluate 5x to the power of 2, x approaching 3. This is the power law. For example, like this. Power law, and also we have the constant multiple law. So I bring the constant outside. I will get 5 limit x squared. And x is approaching 3. Okay. So what would I get is equivalent to 5 and then limit x approaching 3 power of 2. I can do this as shown in here. Okay. All right. As x approaching 3 and x is continuous, so x approaching 3, you replace x in here. 5, x approaching 3, it will be 3 here and then power of 2. So 3 power of 2, you get 9. 9 multiplied with 5, you get 45. All right. I will upload the annotated notes after this. All right, let's look at this example. Example 1.3. Now, we have limit here, x squared plus 8x minus 20 and x approaching negative 2. All right. So, the x is linear at negative 2. So it exists and also linear at negative 2. So now you replace negative 2 with the x here. Negative 2 power of 2 plus 8 multiplied with negative 2 minus 20, negative 2 minus negative 2. So you get negative 32 over negative 4, which is equivalent to 8. As we have seen, we may easily evaluate the limit of polynomial and limit of some, but not all, rational function, meaning that it exists at any point. It is continuous. So if it's rational and also continuous, we can use direct substitution. However, it is currently possible for limit fx x approaching a to exist when fa is undefined, like this. Fa is undefined. Where meaning that it is discontinue at certain point, like this, like this case. All right. So if for all x not equivalent to a, the fx exists, which is equivalent to gx over open sum interval, containing a. So usually we can evaluate the limit by factoring or rationalizing that function. How? Okay, let's look at the scenario like this. This is the function of fx equivalent to x. This is too small. F x squared minus 1 and then x minus 1. All right, we can use using factoring. So this can be transformed into x plus 1 x minus 1. I hope you guys still remember lah, from school that if you have the function of x squared minus b squared, this is actually a plus b, a minus b. So if you multiply it back, you will get that format. I hope you still remember that during school time. All right, and from here I transform it to this um factor, and then divide by x minus 1 from here. So I have x minus 1 here. So this one I can easily remove it. Okay, so it become limit x approaching 1 and x plus 1, which is this is linear. So this is actually limit x approaching 1, x plus, I use what do you call, addition law, as I mentioned and the above, x approaching 1, but then this is constant 1. So this one will get 1 here, 1 plus 1, you will get 2. Okay, because this one is constant. This one you replace it 1, you will get 2. All right, I continue this in the next video.